Okay, Krish, you had asked this question from the comprehensive test. If 0 is less than or equal to theta, less than or equal to pi, and 81 to power sine square theta plus 81 to power cos square theta is equal to 30, then you define the value of theta. So first thing we have to do is let's try and express this equation in a different manner. So 81, that's our equation that we've been given, and since 81 is 3 to the power 4 and 30 is 3 plus 27, we can write this in this manner: 3 to the power 4 sine square theta plus 3 to the power 4 cos square theta is equal to 3 to the power 1 plus 3 to the power 3. Now we also know some trigonometry, so the identity relating sine theta and cos theta is sine square theta plus cos square theta equal to 1. Now in my equation here I've transformed it to have 4 times sine square theta and 4 times cos square theta. So I can see that 4 times sine square theta plus 4 times cos square theta will be equal to 4, and that's equal to 1 plus 3. So I've got all the indices now, yeah? So I've got 4 times sine square theta plus 4 times cos square theta is equal to 1 plus 3. So everything in the indices has been accounted for. We will encounter this shortly, so hold on. Also we know that sine square theta and cos square theta must lie between 0 and 1, which means 4 times those values must lie between 0 and 4, which means 3 to power those values must lie between 1 and 81. So we've established some bounds for 3 to the power 4 sine square theta as well as 3 to the power 4 cos square theta. So now a little more conceptual analysis here. We'll consider the first quadrant. So when theta is in the first quadrant, that means theta is in the interval 0 to pi by 2. As theta increases, sine theta increases and cos theta decreases. So let's take the extreme values. When theta is 0, I can see that 3 to the power 4 sine square theta will be 1 and 3 to the power 4 cos square theta will be 0. It will be 81. And I'm identifying f theta is equal to 3 to the power 4 sine square theta plus 3 to the power 4 cos square theta, and that turns out to be 82, which is greater than 30. At the other extreme, when theta is pi by 2, then 3 to the power 4 sine square theta is 81 and 3 to the power 4 cos square theta is 1, which means f of theta is again 82, which is, as we've seen, greater than 30. At the middle point, when theta is pi by 4, 3 to the power 4 sine square theta is 9 and 3 to the power 4 cos square theta is also 9, which means f of theta is 18, which is less than 30. So from these 4 statements that we have here, we can conclude here that f of 0 is greater than 30, f of pi by 4 is less than 30, f of pi by 2 is greater than 30. Also, because sine theta keeps increasing in the interval and cos theta keeps decreasing in the interval, we can conclude that there must be one and only one value x1 in the interval 0 to pi by 4, such that f of x1 is 30. Yeah, because it crosses from 82 to 18, so it must cross 30 at some point. And there must be one and only one x2 in the interval pi by 4 to pi by 2, such that f of x2 is equal to 30. Yeah, because again it crosses from 18 to 82 as it goes from pi by 4 to pi by 2. So there must be one value between 0 and pi by 4 and one value between pi by 4 and pi by 2. Similarly, dealing with the second quadrant, we can conclude that there must be one value x3 in the interval pi by 2 to 3 pi by 4 and another value x4 in the interval 3 pi by 4 to pi. So we are looking for 4 values. We should be getting 4 values. That's the whole idea, yeah, of this analysis, because we don't know how to solve that equation yet. Yeah, so let's deal with it. We need to find 4 values. So our original equation, 81 to the power sine square theta plus 81 to the power cos square theta is equal to 30. I can rewrite in terms of base 3, and I can also replace cos square theta with 1 minus sine square theta. So I get 3 to the power 4 sine square theta plus 3 to the power 4 times 1 minus sine square theta is equal to 30. This second term here I can write as 81 by 3 to the power 4 sine square theta, and then multiplying everything, I can get 3 to the power 2 times 4 sine square theta minus 30 times 3 to the power 4 sine square theta plus 81 is equal to 0. Again, expressing everything in base 3, 3 to the power 4 sine square theta whole squared minus 3 to the power 1 plus 3 to the power 3 times 3 to the power 4 sine square theta plus 3 to the power 1 times 3 to the power 3 is equal to 0. And I can see now that I can factorize this here. I've got my middle term having a sum, my final term having a product. And so I can factorize to 3 to the power 4 sine square theta minus 3 to the power 1 times 3 to the power 4 sine square theta minus 3 to the power 3 is equal to 0. Which then leads us to conclude that 4 sine square theta must be equal to 1, or 4 sine square theta is equal to 3, which leads us then further to say that sine theta must be plus or minus half, or sine theta is equal to plus or minus root 3 by 2. But in the interval we are given, where theta is between 0 and pi, that is the first and second quadrant, sine theta is positive, so it lies between 0 and 1, which means I have to discard the negative values up here. So I get sine theta is equal to half or root 3 by 2, which then is straightforward to determine that theta is pi by 6, pi by 3, 2 pi by 3, or 5 pi by 6. In terms of degrees, that is 30 degrees, 60 degrees, 120 degrees, and 150 degrees.